Right, so today we're going to learn a key topic of the syllabus called the forecasting techniques. Okay, and this is a part of section B of the syllabus, and the full name of section B is strategic planning, forecasting, and budgeting. And this area together forms 30% of the syllabus. So from this area, there are a lot of multiple choice questions that come. To be exact, there will be 30 MCQs from here. Plus, this area also lends itself very well to the essay questions. Okay, so forecasting techniques is one of these areas, one of the three out of these areas. Now, strategic planning is theoretical. It's easy. It doesn't require a lot of questions. So this is something not students do not find that difficult. Okay, budgeting has budgeting concepts and the related theories, the types of budgets, etc. And then there are those calculation parts. Okay, now the calculation questions that come from budgeting generally are just common sense questions. They do not require any sort of prior budgeting knowledge. All right, so all you need to do in order to get good at these questions is practice as many of them as possible, so that once you go to the exam you can do them quickly. But forecasting techniques is an area where you need to have specific knowledge of the forecasting techniques that are covered in CMA part 1 in order to succeed. Okay, so let's start with the basic question: what is forecasting? Now, most of you guys know what forecasting is. Okay, forecasting is when we are trying to predict what is going to happen in the future. And in this part of the syllabus, we are basically looking at predictions in financial terms. So forecasts are basically the things that are the estimates that go into our budgets, right? So we predict the future, we forecast the future, we come up with something that will tell us what's going to happen, right? How you do that can be in a lot of ways, all right? You can do that from your experience. You can predict that something is going to happen just because you feel that way, feeling, intuition, so on and so forth, right? You can also predict what's going to happen into the future based on the past, right? For example, if your company over the last 10 years had a growth rate between 2% and 5%, so you can estimate it to be within this range for the next 5 years as well. Okay, plus you can also forecast what is going to happen to one thing if you know that that thing is generally influenced by another thing. For example, if you're looking at ice cream sales, right, and ice cream sales are always influenced by the weather. So if you know that hot weather is approaching, so ice cream sales will also go up, right? So when you know that there are relationships between two things, and you know that one of those things is going to go up or down, so you know that this will also cause the other thing to go up or down. Okay, this is how we forecast. Okay, now let me give you an overview of the forecasting techniques that we will be covering in the syllabus. Okay, well, in CMA part 1, in forecasting, we will basically cover two kinds of techniques. Okay, there are what we call qualitative forecasting techniques. Okay, and there is something we call quantitative forecasting techniques. Okay, as you can tell from the name of it, These techniques, the qualitative techniques, have to do much more with the quality of something rather than the quantity, right? So quantity means these techniques have to do something with numbers. These techniques have to do something with mathematical models. These techniques have to do a lot with the data that you have, probably which comes from the past. Okay. Now, qualitative techniques, on the other hand, do not rely on any of these, and these will be when you rely on your experience, you rely on your gut feeling, or what we call, in other words, intuition, or you rely on what everyone says, what people say. So basically, when you forecast using a qualitative technique, you're not analyzing the data, or you're not using a model. You're just using your feelings, right? So where do you use these sort of techniques? For example, if you're a grocery store owner, right? You own a small grocery, and every day you have to decide how many bottles of fresh milk are you gonna buy from the supplier, okay? So of course, if you're a small grocery business, you will not keep detailed records of things, or you will not be able to have mathematical models, or it will be something you will not be able to afford. So what you will do is you will just estimate how much of fresh milk you will need for tomorrow based on your experience, or based on what you feel it has been. You will say, all right, it's been 15 years since I've been running this grocery, so between 10 to 15 bottles, all right, maybe I should stock 12. Okay. Now, in the CMA Part 1 syllabus, all you need to know about qualitative techniques is just this. Nothing else. All you gotta know is what these techniques are and why do we use them. Okay? But when it comes to quantitative techniques, you gotta know much more than that. Okay? When it comes to quantitative techniques, there are two further categories. All right. Okay, so quantitative techniques can be further classified into two categories. Okay, the one kind of techniques we call causal forecasting. It is CAUSAL. All right, I think let me erase this. We have something called causal forecasting techniques. Okay, and we have something called time series analysis. These are the two kinds of technique. This is number one. And number two, that fall within quantitative forecasting techniques. Okay, this is quantitative. Okay. All right, so let's go to the next slide and let's look at how exactly those work. Okay. So when we look at, I told you there are two kinds of techniques we gotta know. All right, there's causal forecasting and there is time series analysis. This is causal. This is not casual. What does causal means? Where one thing, when there's a cause and effect relationship, or where one thing is causing another thing. For example, when the weather changes from cold to hot, that will cause the ice cream sales to go up, right? Within causal forecasting, there are two concepts that we gotta know, right? The first one is called correlation, and the second one is called regression. Okay, now before we move into this, let me tell you one thing. Whether you're using causal forecasting, okay, where you're looking at a cause and effect relationship, for example, between ice cream sales and the weather, or you're using time series analysis, in which you use the data from the past, use the time to know what's going to happen into the future. Now, how do you come up with these models, right? Or how do you predict? Both of these are based on, so your prediction are always based on your past experience. Okay, always remember this. All of these forecasting techniques, all of these, okay, including qualitative, quantitative, all of these are based on your past experience. So this was an important point I wanted to highlight from now. Okay, so causal relationship and regression analysis. Okay, regression analysis is, now I can maybe show you in terms of a graph. Okay, here on this side of the graph, let's say that we have our sales. Okay, and here we have something, advertising expenditure. We are looking at causal forecasting techniques where one thing causes a change in another thing. So as you advertise more and more, of course your sales are gonna go up. Is that correct? Yes, that's correct. Okay, so we can come up with a graph something like this. As your advertising expenditure increases, your sales will also increase, maybe in patterns like this, right? Okay, so this graph shows us that as we advertise more and more, our sales, I'm sorry, I just deleted that by mistake. Okay, as we advertise more and more, our sales increase more and more. Okay, so so advertising is causing an increase in sales. Okay, so there's a cause and effect relationship. All right, now I'm showing this to you in terms of a graph. Okay, now if your advertising expenditure is 0 here, does that mean you will have 0 sales? Does that make sense? Do all businesses that do not advertise, do they not have any sales? No, they do have sales. Okay, so this graph is not that realistic. Okay, a more realistic one will be something like this. Okay, whether you advertise or not advertise, you will have a certain amount of sales without that. Let's see until this point in time. Let's assume these are sales of, say, $100,000. Okay, so these are sales of around $100,000 until this point. So as you start advertising more and more, your sales will start increasing from this point onwards. But if you don't advertise, you will still have some sales, right? This. Okay. Now, you guys, I'm sure, have some basic knowledge of math. Now, when we plot something on a graph on this axis, this is always called the x-axis. And when we plot something vertically, this is always called the y-axis. Okay, and this point at which this line intercepts or cuts the y-axis, okay, this is always called the y-intercept. Or in other words, where this line intercepts the y-axis. Okay, and the slope of this graph, okay, shows you that how much does advertising cause a change in the sales. For example, if the slope is something like this, that means it's more steep. That means your advertising expenditure is causing a lot of changes in the sale. If the slope is not that steep, it goes something like this, so that means it's not causing that much of a change. Okay, So when we, from our past experience of advertising, we have these records with us from the past, we can come up with a model to help us predict what our sales are gonna be when we have a certain advertising expenditure. Regression analysis is all about that. So this is the data, okay? This data we have got is from the past, okay? So this data comes from, this is what we know from the past, okay? So from the past, our advertising and sales relationship has been something like this, okay? Now using this, we will come up with a formula to predict advertising based on sales, okay? And that formula is gonna be something like this. The formula is gonna be, I'm gonna say that my sales are gonna equal this fixed amount that I will get. I showed you guys before, this amount, $100,000. Even if I don't advertise or advertise, I will get this for sure, $100,000 or 100K. Plus, I've always known from the past that every time I put $5,000 in advertising, I end up making at least $25,000. So for every $5,000 that I invest in my advertising, I am able to generate additional sales of $25,000, right? So what I will say is that that means that my advertising is generating at least 5 times of this expenditure is generating sales, okay? 5 into 5 is 25, okay? So I'll say that 100,000, which is fixed, which will come to me whether I advertise or not, plus 5 times my advertising expenditure. I've come up with this formula. This formula is called a regression formula or a regression analysis formula. Now I can also write it in another way. The sales is on x-axis, is on y-axis, right? So I can write it as y equals, I will name this y-intercept as a plus, I will call this b. B is the number of times my sales generates, my advertising expenditure generates sales, into x. X is my advertising expenditure, okay? So this is how it works. Okay, so let me explain this formula in a little bit more detail, okay? Y equals a plus bx. This formula is called a simple regression formula, okay? This formula is called simple regression formula, okay? And the formula is y equals a plus bx, okay? Where we know that y is the dependent variable, the variable that will change with the change in the independent variable. In this case, it was sales, right? What is x? X is the independent variable. Now, or sales depends on advertising, but advertising does not depend on sales. So this is the advertising expenditure. Okay. What else do we have? We have A A is the fixed element, or we officially have to call it the y-intercept. And we got B. B is the slope of the graph, and which shows us basically how many times over will our advertising expenditure generate sales. Okay, so a simple regression equation is y equals a plus bx. Okay, and what all of these mean are given here. Okay, now what we assumed here is that our sales are dependent only on advertising and there's a fixed element. Is that how normally company sales work? No. Your sales will be dependent on not only your advertising expenditure, they will be dependent on so many other things. Is that correct? Yes, that's correct. So we have to take consideration of all of those things, okay? Or as many of those things as possible. Now, how will we do that? We do that through something called a multiple regression analysis formula. Okay, in multiple regression, our sales or y equals a, which is fixed, plus b1 x1. Let's assume this is our advertising expenditure, or sales will depend on this, plus b2 x2. Let's assume this is the advertising expenditure of our competitor. So the more this person advertises, the less our sales will be, plus another variable, b3 x3. For example, do people have money, etc., etc., etc. So you can keep adding these, right? This is called a multiple regression analysis formula. So where you have, in order to predict this y, or in order to predict the dependent variable, or in order to predict sales, you are relying not just on one variable, you are relying on a lot of different variables. Like in this case, this was 1, this was 2, this was number 3, and then so on and so forth. Okay? Now, a question comes into my mind. We're trying to predict the future when we are talking about forecasting. Can anybody predict the future accurately? Right? Can anyone predict the future accurately? All right. So does that mean this will always show us what our sales are gonna be when we spend a certain amount of money? No, that's not the case. Nobody in the world can predict the future accurately. That is not something that human beings have the ability to do, right? But why do we still forecast is because, all right, we will not be able to predict exactly what's going to happen, but we're going to predict something that is close to the reality. So if we predict our sales to be 25,000, and in fact they're not 25,000, they're only 23,000, well, we were still close, right? It's not a terrible amount of difference. It will still help us a lot in planning for these amounts of sales. So our aim whenever we are doing forecasting is never ever to predict the future 100% correctly, because that's never something that you can do, but it is to predict in such a way that you get close as possible to the reality. So any forecasting model that you use has to incorporate error in it. Okay, so you have to consider, so any forecasting model that you use, should always include an error term, or it should include something that will tell the user of the technique that, all right, this is not 100% accurate, it can go wrong, but it can go wrong in a certain range. Okay, for example, if we predicted our sales to be 25,000, so we can say that, there's an error term. So we're not saying the sales are gonna be only 25,000. This could be plus 5,000, or this could be minus 5,000. So in forecasting, we always use the range rather than having a fixed figure, right? So you will say that, all right, if minimum we'll get a sales of 20,000, and if things are brilliant, we might get 30,000. Okay, so this is because of an error term. Okay, now in this formula that I showed you, did we have error term anywhere? Did we include error? No, we did not include error anywhere. So the formula is incomplete. The error term comes right here. So this is your perfect simple regression analysis formula. And this is your perfect multiple regression analysis formula, right? So y equals a plus bx plus the error. This is all there is in regression analysis. There is nothing more than this in this part of the syllabus. Okay, this is what we studied in regression analysis. So let me just summarize it for you guys. So in regression analysis, all we have, or all we are concerned about, is a formula. Okay, and the formula of regression analysis is y equals a plus bx plus the error. This is the sales, or the dependent variable y. X is the independent variable. A is the fixed term, or the y-intercept, and b is the variable coefficient. Okay. All right. This is all there is in regression analysis. Y equals a plus bx. So what is there in correlation? Okay. From the name, all right, what does regression mean? Regression just means regressing a value of x against a value of y, or plotting x against y on a graph. That is what regression means. Okay, this process is called regression. Okay, now what is correlation? Okay, correlation, as the name suggests, is when we are studying the relationship between two variables. For example, sales and advertising, just like we did in the regression analysis formula. Now, sales is always the dependent variable, and advertising is always the independent variable. Okay, this is what we learn in this formula. Okay, What we learned in correlation is something almost exactly the same, okay? So what we learn in correlation is we study the relationship between two variables, okay? There are three things you gotta know in regression and correlation. The first thing is you should know about a concept called, or a figure called, correlation coefficient. The second thing you gotta know about is something called the second one is something called coefficient of determination. And the third thing you gotta know here is something called the t-score. Three things here. In regression, just one thing, which is a formula. And in correlation, you got to know about three concepts: correlation coefficient, coefficient of determination, and the t-score. So let me tell you exactly what these three things are. Okay. So the correlation coefficient okay. Now, what does correlation mean? Where two terms or where two things are related to each other. For example, sales and advertising are related. The more you advertise, the more your sales will be. That's correlation. Okay. What is the meaning of coefficient? All right, it's a very fancy term. Very fancy term, but it just means a number. So you can also call it a correlation number, or a number that shows the relationship between two things or two variables, okay? And there's a symbol of correlation coefficient, okay? What's the symbol? The symbol is R, small letter R, okay? And what does the correlation coefficient show? It shows, number one, the strength of the relationship between two variables. And number two, it shows the direction of their relationship. Okay? What strength means is how strong the relationship is. That means every time you advertise, does it really affect the sales a lot, or it doesn't? If it really does, it's a strong relationship. If it doesn't, it's a weak one. Direction means that when your advertising expenditure increases, what happens to sales? Do the sales increase or do the sales decrease? If when one variable increases, the second also increases, this is a positive relationship. Okay? Just like when we advertise, the more we advertise, the more our sales are gonna be, right? Sometimes you can have a negative relationship as well. For example, what happens if your competitor advertises? If your competitor's advertising budget increases, then your sales will always decrease. That's a negative correlationship. Okay? So correlation coefficient shows two things, right? It shows the direction and it shows the strength of the relationship between two variables. Okay, and it is represented by the number or sorry, by the letter R, okay? And it will always fall within a range of -1 to +1, okay? If it is, and in between, of course, you have 0, okay? So if the R of two variables, for example, advertising and sales, is +1, that means they're perfectly related and they're positively related. Minus means they're negatively related. Okay. So plus and minus shows you whether the relationship is positive or negative. What shows you how strong the relationship is, all right? The closer the number R is to 0, the weaker the relationship. Okay, the furthest away it is from 0, the stronger the relationship. Whether it's positive or it's negative. That's a very important point to remember. So even if it's -1, it's minus. It's still, although it is negative, the direction is negative, but the relationship is very, very, very strong. Why? Because it's away from 0. Okay? This is all there is in correlation coefficient. Correlation coefficient is a number that shows how is the relationship between two variables, okay? It's represented by the letter R. Its ranges from -1 to +1. It will never go more than this, never less than this. In the middle you have 0. The closer a value is to 0, the weaker it is. The farther away it is from 0, the stronger it is. Okay? Okay. And it shows two things, the strength and the direction. That takes us to the next concept. Okay? Correlation. The next one is called the coefficient of determination, and this is represented by the letter R square. So you take the correlation coefficient, this, and you square it and you get coefficient of determination. Okay, now correlation coefficient, or R, shows us the strength and direction, right? So for example, if for R was 0.7, what does it show? It shows us, number one, it's a strong relationship because it's away from 0, closer to 1. And number two, it's a positive relationship. Okay. Now, when we take square of that, let me just take a square of 0.7. 0.7 square gives you 0.7 square gives you 0.49 or 49%. Okay, so what the coefficient of determination shows us is, it shows us, okay, so correlation coefficient of determination shows us how much of a change in one variable, for example, let's say your sales, is caused by a change in the other variable, which in this case was, or advertising expenditure, right? So how much of a change in sales is caused by a change in advertising expenditure? This figure of 0.49 or 49% tells us that 49% of a change in our sales is because of advertising expenditure. 49% of change in sales is always because of advertising, and the rest of it is because of other things. Okay, this is all there is in coefficient of determination. Coefficient determination shows us how much of a change in one variable is caused by a change in the other variable. So if I say that my R square for advertising and sales is 0.10 or it's 10%, that means only 10% of a change in my sales is caused by advertising, and the rest of it is caused by other things. So that means I cannot really use my advertising expenditure to predict my sales, because I can only use it to predict 10% of my sales. But that's not what I want. I want to predict 100% of my sales. So I need to use something else for that. Okay. Now let's go to the third concept in this, which is called the T-score. Okay, T-score is a number that shows the long-term relationship between two variables. In other words, if I tell you that the R of my advertising and sales is 0.7, wow, you'll be happy. You mean a lot of a change in the advertising in your sales is happening because the advertising expenditure, and they are related. But what R shows you is this shows you a short-term result. The R might be for 1 year. The T-score shows you the long-term relationship. So if your advertising and sales in just 1 year, their correlation coefficient was 0.7, next year was something else, that means it's not that reliable in the long term, right? Okay. So all you need to remember about T-score is that once you're given two figures, advertising and sales, and you use advertising to predict your sales, your T-score always should be equal to or more than 2. If the T-score is less than 2, that means the relationship is not very strong and you will not use that to predict the independent variable. Okay, so this is what we have learned. Let's go back. So regression analysis has a formula, that's it, and correlation coefficient, as I showed you, and correlation has 3 concepts we have to know about. Okay, there is correlation coefficient, which is represented by the letter R. Okay, its range is from -1 to +1. In between you have 0, right? So if something is closer to 0, it's weak. Something is away from the 0, the relationship is strong. Okay, it shows 2 things. It shows the direction of the relationship, and it shows how strong the relationship is, strength. Correlation coefficient is represented by R squared. Okay, and what it shows you how much of a change in one variable is caused by a change in another. That's it. What's the t-score? The t-score is the long-term correlation, which should always be more than. Okay, so just to sum up everything real quickly, let me tell you that I said that there are forecasting techniques, right, that we need to learn in this part of the syllabus, and there are two of them. There are qualitative techniques. There are qualitative techniques that do not require numbers. Those are more relating with experience and those things. And then there are quantitative forecasting techniques. Okay. Under quantitative techniques, we have two kinds of techniques. We have causal forecasting, where we look at the cause and effect relationship, and we have time series analysis. We will study about time series analysis in the next video, okay? And all you got to know about qualitative techniques is that this is something which is not based on numbers, but it's based on more general terms. Under causal forecasting, we learned about two things, which was regression, which just had a formula, y equals a plus bx plus error. And we learned about correlation. Correlation had three things that we learned about. Number one was the correlation coefficient, R, which has a range from -1 to +1, and which shows the strength and direction of the relationship between two variables, for example, advertising and sales. Then we had something called the coefficient of determination, which is represented by R square, and it shows us what percentage of a change in one variable is caused by a change in another. For example, what percentage of a change in sales is caused by a change in advertising. And then we have something called the t-score, which just shows us the long-term relationship between two variables, and this always has to be equal than or more than 2. That is it. In the next video, I will talk more about time series analysis. Okay. Now, this area of the syllabus, forecasting, it does not have that much of a knowledge. In just a 1 hour class, you can cover almost all of these techniques. But what it requires is, it requires a lot of question practice in order to excel in this area, right? So my tip for this part of the syllabus is practice and practice and practice. That's the best way to study forecasting. You don't have as many concepts to learn about, it's brief, but you need to practice a lot of questions in order to pass.